Alright, welcome back to another Math Notes. This is Mr. Jewell. We're looking at Laws of Exponents today, and this is section 1.3.2 in your book. We have several laws to cover and review here. We'll go through them real quick and then give you some practice problems on the next slide. So let's start off. In the expression x to the third, you need to know that x is the base and 3 is the exponent. So whatever's being raised to that exponent is the base, and the number there or variable is the exponent. It's also important to remember that x to the third can be written as x times x times x, just the same way that like 3x could be written as x plus x plus x. So you want to keep those ideas sort of separate in your head. When there's a coefficient, we're multiplying 3 times x, that's repeated addition, and when we're raising x to a power, that's repeated multiplication. So let's take a look at these laws of exponents. This first one is x to the m times x to the n equals x to the m plus n. That means that if you have two expressions with the same base and different exponents, you can just add the exponents. So they give you an example here. X to the third times x to the fourth is the same thing as x to the seventh. There's a nice little reason for that, and sometimes on a quiz I'll have students say, pretend we're in a land with no exponents and rewrite the expression without any exponents. So if we think about this, we have x to the third times x to the fourth. Well, let me make these exponents here. X to the third times x to the fourth. And I'll put little parentheses around these for now. I should have done that first. Alright, we'll just put a little space between them. So x to the third, I can rewrite that as x times x times x. So that's my x to the third. And then I'm going to multiply that times x to the fourth. Well, that's x times x times x times x. So really all I'm doing is multiplying 3 x's together and 4 x's together. So I have a total of how many x's? I've got 7 x's there, all being multiplied. So that's going to just be x to the 7th. So that's why we can add those exponents there when they're the same base. Alright, the next rule that we have, we want to look at, let me see if I can stick that over here somewhere. Alright, you guys know what it is. We'll just put it down here at the bottom. Alright, similarly, if we have x to the m over x to the n, you can subtract the bottom exponent from the top exponent as long as the bases are the same. So if we had x to the 10th over x to the 4th, meaning divided by x to the 4th, then that would be x to the 10 minus 4, or x to the 6th. When you're multiplying exponents, when you have a power to a power, so x to the m then raised to the n, you can just multiply those powers. So x to the 4th raised to the 3rd power is the same thing as x to the 12th power. A couple quick ones here at the end. Anything raised to the 0 power is 1. So x to the 0 power is 1. If we had a relationship like y to the 2nd over y to the 2nd, we would subtract 2 from 2. We'd end up with y to the 0, which would be 1. If you want a sort of rationale for that, imagine that we just came in here and drew a big 1 because we have the same thing in the denominator and numerator. So whenever you have the same number over itself, you get a 1, right? Finally, the inverse function, that's x to the negative 1. X to the negative 1 essentially just flips whatever fraction you have. So x to the negative 1 is the same thing as 1 over x. So if we had 1 over x squared, we could pull out the square and have 1 over x times 1 over x, which would be 1 over x squared. Rewrite the inside as 1 to the negative x times 2, because now we're doing power to power. and we get x to the negative 2. So what this is showing you, sorry for this sort of explanation popping up here. What this is showing you is that when you have a negative exponent, it's kind of on the wrong side of the fraction bar. That's the other way that I explain this when we're talking about negative exponent. So we have x squared on the bottom. If we want to move it up to the top, we have to change the sign to negative 2. Right now, this is on the top, x to the negative 2 over 1. If we want to make the exponent positive, we move it down. If we thought about it like this, we have x to the negative 1. It can be written as x to the negative 1 over 1. If we want to make the 1 positive, we move it down, so that would be 1 over x to the first, like that. All right, guys, let's take a look at some examples. Here, we want to simplify the following and state which rule you just used. So jot down these 6 problems and see what you can do with it.